Okay, hi everybody. I just want to take a couple seconds here and talk about inequalities. Again, this is about notation. After teaching for a long time, I really do get the sense that in some ways perhaps we've done a disservice because I come across a lot of people that really don't understand inequality symbols, and I just want to talk about that really briefly here. Apparently that whole idea of the alligator wanting to eat the larger amount, and so it opens up towards that larger amount, that hasn't rung true with a lot of people, or at least they're not seeing kind of the logic of that. So what I want to do right now is just very, very quickly explain the notation, because there is real genius in mathematical notation. And you just got to get it. You just understand why the symbols represent what they represent. It makes a heck of a lot of sense here. So for example, if we started off with 5 and 5, okay, those two values are equal. So we would put the equal sign in between them. But let's talk about that equal sign here, okay? What you've got here are two parallel lines. Now, we get so used to that we don't exactly appreciate the genius behind this. What we've got here is, with the two parallel lines here, the reason why this means equality is because the distance between the endpoints are the same. With two parallel lines, once we cut those off, two parallel line segments, you might want to say here, at either end of those segments, the distance between them is the same. Well, it's the distance between those two values, the distance between those two endpoints, that communicates to us that the value on this side and the value on this side are equal. Now, if we change this up, let's maybe increase the value of this end by 1, decrease this one by 1, so now we've got 6 and 4. Well, now we can't use the equal symbol, okay? Because there's more here on this side than there is on this side. So the symbol that we use is designed to reflect that. So instead of being two parallel lines, they can't work like this. We want the distance between those 2 points to be larger on this end and smaller on this end. Now, but in our notation, we're going to kind of exaggerate what it is on the small end. We're going to have those two come together. The distance between the two endpoints on this end is larger than it is on this end. Okay? So that, because this value here is greater. Remember, the value is represented in essence by the distance between those two endpoints. Now, on the other side there, they're infinitesimal, they're connected, okay? So there's really no distance there, but it's meant to just be a representation that this side here has a larger amount than that side, okay? So in essence here, what we end up with is an arrow pointing towards the smaller value, and then it opens up towards the larger one. Likewise, if we flip these around, okay, the larger value is over here. So the distance between the endpoints on those two line segments has to be larger on the side where the value is greater. Okay. Now, let's just talk very quickly about one other little issue that pops up repeatedly with inequalities here, and that's what happens when you're moving a negative here. Let's say that we've got, let's say, -6 and 3. Okay. Well, obviously 3 is larger, so the distance between the endpoints of those two lines has got to be larger on the end pointed towards the 3. The negative here, the way to think about this is this can be interpreted as -1 times 6. Now, I haven't done anything to that. Okay, I'm just really representing this a little bit differently, separating the negative from the value here. If I now multiply both sides by the negative, okay, this value here is negative, okay, this value here is positive. When I bring that negative over, okay, by multiplying both sides by a negative, so I'll do that like this, and I'll multiply it here, I've done the exact same thing to both sides. Okay, it's important that you catch that, because if this was an equality, doing the same thing to both sides would maintain the equality. Doing the same thing to both sides should, in essence, maintain what's going on here. But in this case, when you're dealing with inequalities, no, it doesn't. Because the negative times the negative creates the positive here, and then the 3 becomes negative on that side. So what we've done, in essence, is moved where that negative is to the other side, and now the direction of the sign has to change, because now the 6 is positive. It's larger than its negative kind of counterpart there. Now, so anytime you either multiply or divide by a negative, that's going to happen. Now, addition or subtraction doesn't do that. Okay, when you add a negative or subtract a negative, it's not going to affect the sign here. Now, I can show you really quickly, just by example here. If we, for example, take the negative 6, and let's say we get negative 6, we got the 3 here. Let's say that we add 3 to both sides here. Okay, so initially we had this symbol here, 3 plus negative 6, negative 3, 3 plus 3, 6. Well, that relationship is still maintained. The left-hand side here is still smaller than what's going on the right-hand side. Now, and that probably makes sense to a lot of people. I don't think that's the really confusing one. Where this might get a little confusing is you got something like this, negative 6 and negative 3. Okay? Now, the way to understand this is simply to think about how negatives work. Negative 6 and negative 3, which is smaller? Okay, well, negative 6 is smaller. In spite of the fact that the value 6 is larger than the value 3, the negative sign, okay, implies a direction along the number line. So you just think about it like this. You know, a lot of math confusion could be alleviated if you just thought of things in terms of like number lines, basic ideas that we started with way back in elementary school. Here's negative 6, here's negative 3. The further you are to the left on the number line, technically the smaller that value. So it's got to look like this. Now, if you multiply both sides through by a negative, this becomes positive, this becomes positive. Again, because they both become positive, when you're on that side of the number line, the relationship switches here. Okay, and then that larger value is in fact further to the right, so it becomes larger. So the symbol that we use to communicate that's got a switch here. It's got to be further apart towards the 6 than it is towards the 3. Anyway, so multiplying and dividing by negatives will change that sign. I just really wanted to spend some time making sure that you understood what the notation means and you see the genius in it. Now, hopefully that helps. Otherwise, this has just been another math monologue where nobody was listening.